Hi there, my name is Janice Nowakowski, and I'm the District Teacher Consultant for Mathematics and Numeracy in the Richmond School District. Welcome to a new series of burst sessions and videos we're doing on how to use math materials across the grades kindergarten to grade 9. And this very first one is about Unifix cubes. So as we think about why we use math materials, in our curriculum in British Columbia, from kindergarten all the way through grade 12, we have a learning standard that's a curricular competency that states that students will represent mathematical ideas in concrete, pictorial, and symbolic forms. So regardless of what grade level you are teaching, you look at the concepts that you're teaching and you think about how students will represent those ideas in different ways, in different forms. So concretely with materials, pictorially through visuals and pictures, or symbolically or in abstract forms. And there's a lot of current research around that sort of idea of concrete, pictorial, symbolic, which is what we call it in our BC curriculum. But generally in the mathematics education research, it's called CRA, concrete, representational, abstract. And when this was first named, it was really thought that it was a linear progression, that students start at the concrete, then they move to representational, then they move to abstract understanding. And what our current research is showing us, and Dr. Kathy Marks-Kirpan out of Oise in Ontario is one of the researchers in this area, talks a little bit more about the interplay between all three representations, that it's not a linear progression, that students that have a deep understanding of a concept can move between all three forms flexibly and fluently. So that is the goal. On the right here, you see an example of that. This is one of Kathy's sort of structures that she uses. So a concept circle, you might have a number or a fraction or something in the middle. And then students represent that in different forms, pictures, numbers, words, materials, etc. And it's that fluency and flexibility between going all those forms, which deepens their understanding of the concept. So that's sort of the background in terms of why we use materials. As we're developing our district's numeracy foundations framework for kindergarten through grade 12, each grade band framework, the K-2 and the 3-5 ones are already developed. There is a page on mathematics materials for those grade ranges and where to order the materials and how to use them. So those are, it's also an important part of our district strategic plan and numeracy foundations in our district. So what are Unifix cubes? These are the Unifix cubes here. They're 3/4 inch little plastic cubes that were invented in 1953. So these materials have been around a really long time. They're one of the really foundational, commercially produced, mathematically structured materials. So when I say mathematically structured, I mean that they're structured specifically to do mathematics with, as opposed to some other materials that can be used for a variety of things like buttons or popsicle sticks, etc. They were invented by Charles Tacey. They're plastic cubes and they can only be connected on the two ends. And so the bottom end and the top end are where you connect them. And that's why they're called Unifix cubes. They go in one direction only. And they come in multiple colors. They continue to be produced by Didax, which is a huge math manipulatives company. They are not what these cubes are. So often in classrooms, we also have these types of cubes. And these cubes can be connected on all 6 faces. So they can turn, they don't just make a linear tower or train. You can make other types of shapes with them and connect them in different ways. So these are called multi-link or interlocking cubes, or sometimes just linking cubes. And clearly you can make different kinds of structures with those. So you could make a rectangular prism. You can play with, spatial reasoning and create different combinations with 5 cubes that you won't be able to do with Unifix cubes. They're much harder for younger children to use, or children that have grasping, fine motor. Their fine motor development doesn't allow them to grasp, or their strength doesn't allow them to pull them apart. These are much more difficult to use, these interlocking ones, than the Unifix cubes. So again, when we're thinking about our youngest children, or we're thinking about children that need adaptations or accommodations for the materials they use, Unifix cubes are the most accessible cube that we have in our schools. So again, I invite you to pull out your Unifix cubes and play along as I share some different examples of ways to use them. So I went through curriculum, kindergarten through grade 9, and just sort of brainstormed a list of all the different ways I've used Unifix cubes in my teaching when I'm in classrooms. So, very simply from counting, often we use these to model different ways to count. So having a collection of them out and then either moving them as we count, that one-to-one correspondence, or making a tower with them and then pointing to each one, again, for that one-to-one correspondence, basic counting, decomposing and composing quantities, different ways to make 10, ways to make 5 with 2 colors, with 3 colors, etc., and playing with those different parts and wholes. Adding and subtracting, grouping and multiplying and dividing, representing those quantities. With older students, representing 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm just counting up my tower here, representing fractions, decimals, ratios, and percentages. So in this tower of 10 cubes, I have 3 orange ones. So that would be 30% of this tower is orange, or 0.3, or 3/10. And having students go flexibly between all those representations using a tower of 10 with different colors. Now, this can be confusing for some students that the oranges are, interspersed. So you could group them by color as well, like I have for the blue here. So that would be 2/10 or 20%, etc. The white would be 10% or 1/10. So those can be used with older students as well, usually in quantities of 10, but then you could play with the idea of just doing 5. And then how do you use that to connect to tenths and percentages, etc.? What do you multiply by? So lots of connections there. Non-standard measurement. So again, these aren't a centimeter or an inch. They're 3/4 of an inch. But you can, how many cubes tall is something, or how many cubes long is something? And this is what we would call uniform non-standard assessment, because these are all the same size. So they're uniform. Lots of teachers use these for patterning, whether it's repeating patterns or increasing and decreasing patterns. So I remember as a primary teacher, it would be a rainy recess and I would come back and there would be a row of like Unifix cubes out into the hallway with some sort of pattern, red, yellow, red, yellow, red, yellow. And so students have been making patterns with these for decades. So that's a really common use of Unifix cubes, but we can also use them for increasing and decreasing patterns. And I'll show some examples of that. One of the things I like to do starting around grade 3, grade 4 is to use these to introduce bar graphs. So introducing a concrete form of bar graphs. So you might have a tub of Unifix cubes out and you might have, a legend on your whiteboard. Question is, what is your favorite sport? And you might have hockey, soccer, tennis, other. 4 choices and a color assigned to each of them. The children choose the color of cube and begin to stack them up and make towers. And then you can compare your results and then create a pictorial representation of that concrete graph. And then again, increasing and decreasing patterns leading to algebraic thinking. So I've been learning to make reels on Instagram. So this is a very short reel that I'm going to share with you here on some different ways to use Unifix cubes. And it might suggest to you ways that you could have students represent their mathematical understanding through photos or videos and annotation on apps that they could then post to their e-portfolios or that you could share with families. So this doesn't have any sound to it. So, it's supposed to be playing. Oh, there we go. So I used a stop motion app to create a 10 frame with the 10 different colors of the Unifix cubes. Again, the pattern trains, AB patterns. I usually call them trains and towers going up. So that would be an ABB. And again, students could take a photo and then annotate it with the letters to describe the pattern. Different positional patterns, up, down, up, down. Here's an increasing pattern. And then again, decomposing 5 and 5, different ways to make 10 using different colors, comparing and finding the difference, measuring, doing a survey and graphing, fractions, decimals, percent, skyscraper games. I'll share a little bit more about that. But those are just some ways to use Unifix cubes. These are skyscraper puzzles. For those of you that teach grade 3 and up, these are a great spatial reasoning task that focuses on quantity and patterns, area, perimeter, And I'll share the link in the chat after the recording is over, but I've also posted it there. You can also Google Mark Chubb blog, skyscraper patterns, but it's essentially a 4x4 or 5x5 grid that students create towers in. And so you can see the photo on the right. In that first column on the left there's one of each size of tower, one that's 1, one that's 2, one that's 3, one that's 4. So you can't have any repeats in any column or any row. So that's what's a little bit tricky. Students will put down one, but then the next one they have to build on what they've already done. So that would sort of be the starter version. And then the next version, and this is what Mark has on his blog, and he's a Canadian who shares widely, they look like this. And so these numbers indicate how many towers you can see when you're looking like straight on from each side of the grid. And there's videos on his website that explain this a little bit more, but you could do this as part of a geometry unit. You could do it as a spatial reasoning task. And for some of those children that really like puzzles and extension activities, the skyscraper puzzles are great to do with Unifix cubes. Algebraic thinking is another thing that I often use Unifix cubes for because they're simple to use. You can use different colors. And they're easy to, again, click together or snap together. So this is an example using virtual manipulatives. So using the Unifix cubes online, and then using the drawing tool online to create a chart. So this is connecting, again, the materials to the symbolic representation that's leading to algebraic thinking. Okay? So you could also then, from this, create a graph as well. So those of you that are grade 5, 6, 7 and beyond, this is where we go from, looking at growing and increasing and decreasing patterns to an ordered set of pairs in a T-chart to the graph that corresponds with that. And we're generalizing that rule. You can see the expression there, n+1. And the nice thing again about the Unifix cubes, because there's different colors, it makes it really clear here what the constant is. Those orange cubes are that +1, and students can see that. And then the n is the term. So the first term, there's 1 blue. The second term, there's 2 blues. And you can see that really clearly with the Unifix cubes, whether you're building it concretely or using the virtual manipulatives. 2 key resources for Unifix cubes are this book, Developing Concepts Using Unifix Cubes. Kathy Richardson is a math educator and researcher out of Bellingham. Amazing resources. This book is out of print, but you can buy it online used. And most of our schools, I've checked on the DRC catalog, most of our schools have it in the professional library. And then the other resource is those virtual manipulatives that look just like the Unifix cubes because they're created by Didax, which is the company that makes Unifix cubes. And then just for each session that we're doing on math materials, I'm going to share just a couple of tips for storage and facilitating the use of math materials. I like to have one tub of each math material visible to students and accessible to students at all times. It may not be all the Unifix cubes I have, but I have a tub or a basket or a container that students can see and have access to so that they know, oh, I could use Unifix cubes for this. And so it's sort of enabling their agency in terms of what materials might support their learning. You might have a whole bunch more Unifix cubes in a storage room somewhere, but having some available all the time, I think that students can see is really important. And then having a container for each of your table groups, a basket like this or a Tupperware container or something that you can put a collection of for small group work at tables so that if you're doing specifically something around patterning, that group has access to those. So those are just 2 particular storage tips for materials in general. So as we finish this burst session, I want you to think about how will you use Unifix cubes to support student learning? And thank you for joining me today.